Welcome to the Sleepy Science channel. Here, we use soothing sleepy bedtime science stories to unveil the tranquil mysteries of the universe for you tonight. Let's relax our minds and embark on a gentle journey into a world of science and dreams. Surrounded by the 432 Hz Earth frequency, this video, a 2.5-year endeavor spanning 188 minutes, will take you on a profound journey through cosmic knowledge. From the Big Bang to Earth's unsolved mysteries, by the end, your understanding of the universe will transform fundamentally. Scientists believe in as little as 22 billion years, the cosmos will meet its ultimate fate. Earth will disintegrate in the final minutes. Every atom in the universe will dissolve in the last second. This is the cosmic finale known as the Big Rip, the driving force. Our universe has been accelerating its expansion. As early as the 1920s, Hubble discovered galactic redshift, proving most galaxies are racing away from Earth. Over half a century later, astronomers made another breakthrough. The cosmic expansion is accelerating. The farther a galaxy is from Earth, the faster it recedes. At 14.5 billion light-years lies a threshold. Beyond this point, galaxies flee faster than light, severing all connection with Earth forever. Of the 2 trillion observable galaxies, 98% have already crossed this boundary. In essence, Earth is being isolated by the entire cosmos. The reason? All visible matter constitutes merely 5% of the universe. The rest, 25% dark matter and 70% dark energy. Dark energy, the prime culprit behind accelerated expansion. It overwhelms gravity on cosmic scales, diluting the density of matter relentlessly. If acceleration continues at this rate, in 21.8 billion years, systems like the Laniakea supercluster will begin fracturing into smaller fragments. After another 140 million years, expansion forces will reach 100,000 light-year scales. The Milky Way and Andromeda will start disintegrating. Galaxies will cease to exist, leaving only scattered stars. 3 months before the Big Rip, repulsive forces will act on light-year scales. Our 2 light-year wide solar system will fly apart. Earth and the Sun will drift endlessly apart. In the final minutes, expansion will target planetary systems. Spatial repulsion will overcome Earth's binding energy, tearing our world apart. The expansion continues its relentless march. Down to the last Planck instant before the rip, 10 to 19 seconds. Every atom in the cosmos will be shredded. The universe becomes a primordial particle soup. Atoms, molecules, celestial bodies, galaxies, black holes, all vanish into oblivion. Yet this apocalyptic vision rests on one assumption: dark energy dominates the cosmic energy budget. If future discoveries reveal less dark energy, the universe might shift from acceleration to deceleration. Expansion could halt, then reverse into contraction. Nobel laureate Roger Penrose proposes a cyclical cosmos where the universe might eventually collapse. Matter density would skyrocket. All galaxies merging into a new singularity. Then Dot another big bang, a new universe born from the ashes. While evidence for this cyclic model remains elusive, it offers a compelling cosmological alternative. After all, the Big Bang explains cosmic origins, but not how the story ends in the foreseeable future. Advanced astronomical instruments will record expansion rates with unprecedented precision, though we observe but a fleeting cosmic slice. This momentary glimpse may reveal universal trends. Unlocking deeper mysteries, dark energy, the phantom driving cosmic expansion. What if I told you all visible galaxies constitute just 5% of cosmic content? Those densely packed stars, separated by light years of emptiness. Galaxies themselves drift millions of light years apart. Beyond them lie cosmic voids spanning tens to hundreds of millions of light years. These voids petition the cosmos. Even our Milky Way resides within one. Take the Boat's void, stretching 330 million light years. It should contain 2,000 galaxies. Astronomers have found only 60. Had we evolved there, we might believe the entire universe held just 60 galaxies. Then there's the Eridanus supervoid, a staggering 2 billion light years across. How did these voids form? Astronomers theorize they predate the Big Bang itself. More precisely, the universe's matter distribution was predetermined during the primordial singularity phase, according to Big Bang models. Our universe existed as a singularity 13.8 billion years ago, an infinitesimal point, a random quantum fluctuation triggered superluminal inflation, spawning space-time and matter. Since inflation vastly exceeded light speed, the singularity's matter distribution imprinted itself across the entire cosmos. Cosmic voids expanded from microscopic origins to their current immense scales. Today, space-time still expands faster than light. The farther the galaxy, the faster it recedes. The future Milky Way Andromeda collision, merely a local anomaly from close proximity. The broader universe grows ever more empty. This means if alien civilizations truly exist, their chances of encountering one another diminish constantly. Every civilization might remain trapped in its home system. Intergalactic voids span tens of millions of light years, devoid of energy sources. Superluminal expansion widens these gaps further, isolating intelligent civilizations across the cosmos. Thus, the tetrillion galaxies in our observable universe become tetrillion isolated islands. For humanity today, the solar system itself is an island. Its 2 light-year diameter requires millennia for our fastest probes to cross. Reaching interstellar space takes tens of thousands of years. The Milky Way's 100,000 light-year diameter and 3,000 light-year thickness make galactic exploration impossible, even with light-speed travel. While we believe humanity will enter a spacefaring era, this transition may require centuries, perhaps millennia, leaving the solar system to explore the galaxy tens of thousands of years. More likely, humanity might encounter a great filter, an asteroid impact, for instance. Then, silence, though many intellectually grasp Earth's insignificance in the cosmos, Few truly internalize this reality. The solar system's stability and humanity's brief history have largely shielded us from cosmic threats, but the future remains unknown. Why we can never reach the cosmic age. This is Earth from a space station. Only from hundreds of kilometers up does its curvature become visible. Even from airplanes, the ground appears flat. This classic blue marble shot from 30,000 kilometers away became a software startup screen. Zoom out tenfold. Earth seen from the moon's distance, 380,000 kilometers away. Perspective shrinks our world to a blue marble. Who could imagine this marble hosts 8 billion souls? A bustling, noisy world. From Mars, 160 million km distant. Earth becomes a pale blue dot. Martian atmosphere tints the sun blue. Scientists believe by centuries' end, Mars will host settlements. Thousands working and living there. Zoom another tenfold. Cassini captures Earth from Saturn, 1.4 billion kilometers away. All detail vanishes, a lone speck of light. A careful eye might spot a fainter dot nearby. Our moon ... Voyager 1's pale blue dot. 6.4 billion kilometers from home, a mere 0.12 pixel speck. This image came from a solar system family portrait, Voyager's final photographic assignment. Since then, it voyages outward, never looking back. At 17 kilometers per sec, it needs 30,000 years to exit the solar system, the nearest star, for 0.22 light years away. Over 100,000 years of travel. Scientists then and now agree Voyager won't encounter aliens. The Milky Way spans to 100,000 light years, hosting at least 100 billion stars. Our Sun and Earth are insignificant among them. Astronomers are certain other civilizations exist, but they're too distant. Neither Hubble nor China's fast can easily detect galactic neighbors. Beyond our galaxy lies the local group, 50 galaxies across 10 million light years. The Virgo supercluster, 110 million light years wide, 100 galaxy groups. Then Laniakea, our cosmic metropolis, 100,000 galaxies spanning 520 million light years. A leviathan even in universal terms. These scales reveal light's slowness. 1 year to leave the solar system ... to 100. 0 years to cross the Milky Way ... The observable universe, 93 billion light years across. Beyond any human lifespan, perhaps beyond humanity's entire existence. Present and future civilizations may remain light speed limited to small regions. Perhaps all cosmic civilizations face this fate. Thus ... we may never find others, nor will they likely visit us. The sun's secret, a hidden black hole. Since 1971, Hawking proposed primordial black holes might lurk inside stars, tiny, low-mass black holes sustained by stellar material. Neutrino detectors reveal solar neutrinos fall short by 1/3, suggesting some radiation stems not from fusion, but unknown sources like black hole radiation. Decades later, evidence mounts. Perhaps black holes predate stars. Simulations show an Earth-mass primordial black hole drifting into a nebula could accrete matter, raising temperatures, but its small size prevents rapid consumption, leading to nebular collapse and star formation. More extreme, an atomic-scale black hole might sink into a stellar core over billions of years. It consumes stellar material while radiation pressure prevents runaway growth. Astronomers estimate a hypothetical atomic black hole in the Sun would swallow just 100 tons per second. Compare this to solar wind mass loss, 1 million tons per second, negligible for a star comprising 99.86% of the solar system. After 4.5 billion years, such a black hole might now be 10 centimeters wide, mass exceeding Earth's. In 5 billion years, solar fusion will cease. Its envelope will expand past Mars' orbit, transforming from yellow dwarf to red giant. The black hole would grow during this phase. Since the Sun lacks mass to form a black hole naturally, the white dwarf remnant might fail to constrain it, leading to its consumption and emergence. But billions of years before then, Mercury, Venus, Earth, and Moon will plunge into the Sun's expanding inferno overall, whether the Sun hosts a black hole or not. Studying them remains largely theoretical. Natural black holes lie thousands of light years away. Current colliders lack power to create them for study. Can we see the universe's edge? For astronomers, 46.5 billion light years marks the boundary, the observable universe's limit. Beyond, galaxies recede faster than light, their light never reaching us. They lie outside Earth's light cone. Within this 93 billion light-year diameter sphere, astronomers cataloged a trillion galaxies, the nearest, Andromeda, to 0.5 million light-years away. Gravity pulls it closer. Collision in 3.7 billion years. Trillions of stars will reshuffle into a new galaxy, but these scales dwarf human capabilities, even with current technology. Exploring our solar system remains challenging, let alone the galaxy or cosmos. Voyager 1, launched in 1977, hasn't left the solar system. At 17 kilometers sec, light speed seems tortoise-paced if we develop light-speed ships. Escaping the Milky Way takes 100,000 years, reaching Andromeda to 0.5 million years. Under such constraints, interstellar expansion becomes meaningless. Depart and return to find Earth unrecognizable, time's chasm separating you forever. Hubble and Webb show isotropic galaxy distribution, seemingly uniform, but this is illusion. Cosmic microwave background analysis reveals a filamentary web structure on billion light-year scales. Galaxies cluster into cosmic walls, stretching tens of billions of light years. Voids carved by dark energy separate them. Our Milky Way also resides within a supervoid, with dark energy dominating. Voids will keep growing. Beyond the observable universe, countless unobserved galaxies likely exist, similar to ours, but the ultimate boundary question remains unanswered by current cosmology. Insufficient curvature data ... if curvature measures 0. The universe is an infinite flat plane, if greater or less than 1. It could be a closed sphere or open saddle. These would imply a finite shape, offering hope of reaching an edge beyond the cosmic boundary. Perhaps other universes ... or return to the origin. This mystery remains unsolved. Scientists tell us the universe began with a Big Bang 13.8 billion years ago. But what preceded it? Most physicists reply, no comment. The pre-bang singularity is one of the places where physics breaks down. Simply put, no time, no space, no matter. But this indescribable state is now being challenged. Penrose proposes a cyclic cosmos, where each Big Bang reformats the universe. New universes birth with different physical laws. Our light speed, 300,000 kilometers sec. A previous universe might have 500,000 kilometers sec. The next, perhaps 100,000 kilometers per sec. Observations confirm accelerated expansion, superluminal, in fact. At 14.5 billion light-years, recession exceeds light speed. 98% of galaxies have already crossed this threshold, their numbers growing. Astronomers once thought all galaxies would eventually leave our light cone. The Milky Way becoming a cosmic island. The culprit? Dark energy, 70% of cosmic content. Its repulsive nature opposes gravity, but dark energy remains theoretical, like dark matter, undetectable directly. If future studies show less dark energy, our universe might decelerate, eventually contracting under gravity ... in a collapsing cosmos. Galaxies would approach the observational center from Earth. We'd see more galaxies over time, collisions and mergers would increase. We know Andromeda will collide with us in 3.7 billion years. But in a contracting universe, all galaxies would ultimately merge. Stellar distances would shrink, then planetary ... until all matter compresses into a singularity, another Big Bang, in a new universe with different physics. Even spatial dimensions might change, no longer confined to 3, giving rise to unimaginable life and civilizations. But this process likely spans trillions of years. Thus, our universe remains in its infancy. Humanity might be among the first civilizations, explaining why we find no others. If true, we have no cosmic predecessors to guide us. Returning to the initial question, before the universe's birth, before physical laws existed, we humans are products of those very laws. Thus, our minds may be incapable of comprehending the pre-cosmic state, like an individual unable to recall their own birth. Are we alone in a trillion galaxies? Hubble and Webb deep field images show largely uniform galaxy distribution, isotropic and homogeneous, within the 93 billion light-year observable universe. Galaxy counts approach the trillion. The Milky Way is but one. Even if each galaxy hosts just one intelligent civilization, alien civilizations would outnumber today's global population. Yet, curiously, neither in nearby star systems nor across the Milky Way have astronomers found any alien traces, as if humanity were the universe's sole intelligence. Statistically, this seems improbable. The Sun and Earth aren't special. Among the galaxy's hundreds of billions of star systems, many Earth-like worlds must exist, capable of evolving life and civilization, leaving detectable signs like electromagnetic emissions, or even Dyson spheres. Musk once said, if a fish never encounters its own kind, it lives in purified water. Astronomy has a similar hypothesis. The region around our solar system might be a low-technology civilization reserve, humans being observed and protected only upon reaching certain technological maturity. Would we be accepted by other civilizations? If true, At least we needn't fear alien invasion, but the truly frightening possibility. Humans might indeed be alone. Perhaps Earth alone hosts life. We now know life requires precise conditions: stellar habitable zones, suitable magnetic fields, long-term stable environments. Simultaneously meeting these criteria is rare. In the universe's 13 billion year history, the first stellar generation lacked conditions for life. Only now, 13.8 billion years later, around second generation stars like our Sun, enriched with heavy elements, can rocky metallic planets form, giving rise to carbon or silicon-based life. Thus, the time window for life's emergence is narrow. Humanity might be the first intelligent civilization, Earth the first life-bearing planet within our solar system. Astronomers believe Mars hosted life 4 billion years ago. Then, Mars resembled modern Earth, a blue world with oceans and atmosphere. We just don't know how far Martian life evolved. Future missions may reveal answers. Some scientists even propose Earth life originated on Mars 3.8 billion years ago. A Martian meteorite carrying microbes crashed into Earth's oceans, seeding new evolution. Besides ancient Mars, Jupiter's Europa and Saturn's Titan might host life today with subsurface oceans or atmospheres suitable for microbial survival. As space technology advances, we may discover life or its traces elsewhere in our solar system. Jupiter, Earth's guardian angel. July 16, 1994. Comet Shoemaker-Levy 9, torn by Jupiter's gravity, slammed 21 fragments into the giant. The impact released 20 billion Hiroshima bomb equivalents, exceeding Earth's total nuclear arsenal. Jupiter's clouds bore a scar larger than Earth, lasting years. Every observatory, Hubble, even distant Voyager, turned their lenses toward Jupiter, humanity's first witnessed comet impact event. Scientists and public alike were stunned. 20 billion atomic bombs could revert Earth to prehistoric times. Without Jupiter's gravitational intervention, this comet might have reached Mars' orbit and, beyond, lay Earth. 1990 for human civilization might have shared dinosaurs' fate, wiped out by cosmic impact. The impact also revealed Jupiter's interior, ejecting water ice and heavy elements. Though a gas giant, Jupiter isn't fluffy. Density increases toward the core, transitioning to liquid and solid states. Core temperatures and pressures even create metallic hydrogen. With 2.5 Earth's gravity, Jupiter dominates the asteroid belt, preventing planet formation. Millions of asteroids orbit obediently under its sway. Occasional Earth-crossers pose little threat. Without Jupiter, from the distant Kuiper Belt and Oort-Kloot to the nearby asteroid belt, comets and asteroids would run amok without massive planets. Impact probabilities on Earth and other planets would rise, perhaps preventing life's emergence. With merely centuries of technological history, we cannot yet enter space and masse or colonize other worlds. Thus, asteroid defense becomes paramount. Automated sky surveys now catalog numerous near-Earth asteroids, sometimes issuing alerts, but statistically, asteroids rarely hit cities. 70% of Earth's surface is ocean. Most cities cluster along coastlines. Historical city impacts are rare. Atmospheric entry incinerates most small asteroids. For truly large ones, we remain helpless. Nuclear weapons in space lack shockwaves. Only kinetic and thermal effects remain, greatly reduced. Thus, the foreseeable future requires accelerating space technology development, making humanity a multiplanetary species. Then, even if Earth suffers an impact, humanity needn't vanish from the cosmos, the loneliest place in the universe. Cosmic voids on billion light-year scales. Galaxies form filamentary web structures. The meshes are cosmic voids where dark matter and energy concentrate. Void galaxy densities are 1/10th outside levels. Scattered galaxies and billion light-year voids resemble droplets in an ocean. Astronomers believe, had the Milky Way formed inside a void, we'd still think it the universe's only galaxy, the void constituting the entire cosmos. Typical voids span 30 to 300 million light-years. The observable universe, 93 billion light-years. The Milky Way, a mere 100,000 light-years. Since the 1970s, as cosmic microwave background maps refine, more voids emerge. Galaxy-poor regions appear as cold blue spots. The largest, the CMB cold spot, according to Big Bang theory. Voids existed at the universe's birth. We see their mature forms. Simply put, in the first trillionth of a second after the Big Bang, void and galaxy distributions were determined by quantum fluctuations, then superluminal inflation, magnified microscopic structures to cosmic scales, from quantum to billion light-year dimensions, from particle distribution clumping to universal galaxy densities. All was preordained. First, dark matter aggregated into vast channels over hundreds of millions of years. Then ordinary baryonic matter flowed along these paths. Subatomic particles became atoms. Atoms became gas clouds. Clouds became stars. Stars clustered into the first galaxies. Galaxies form groups, then clusters, then superclusters. These structures now interconnect, a vast cosmic web spanning the observable universe. Regions with low quantum phase densities became voids between cosmic walls, realms filled with dark matter and energy. In 2013, Planck's satellite discovered a new supervoid, 1 billion light-years across. But astronomers believe the largest void surrounds us. More precisely, the Milky Way, Focal Group, even Laniakea, reside inside the KBC void, 2 billion light-years. Why? Some scientists suggest our failure to find aliens stems from the solar system, even the galaxy being special, a low-technology civilization reserve. What the KBC void's discovery implies, this reserve might span to billion light-years. Humanity may vanish before escaping it. Visual. Supernova explosion. Have you seen a star brighter than the moon? AD 1054. Song Dynasty astronomers witnessed a supernova, guest star in historical records. Its brilliance surpassed the moon, allowing scholars to read at night without lamps. AD 1731. British astronomer John Bevis discovered the Crab Nebula, the supernova's remnant. This 11 light-year wide nebula contains a pulsar, now 6,500 light-years away. From stellar physics perspectives, supernovae rank among the cosmos' most violent phenomena. Occurring only in massive stars' final stages, they instantly release energy equivalent to billions of years of stellar output. Radiation and heavy elements scatter near light speed, forming glorious remnant nebula. Virtually all heavy elements, gold, silver, copper, iron, calcium, originate in supernovae. Even our sun formed from supernova debris, hence Earth heavy elements, and us the nearest potential supernova, Betelgeuse, 640 light-years away, a red supergiant with short lifespan, now nearing its end. Recent brightness fluctuations suggest it might have already exploded. We see its 640-year-old light. If we witness its explosion now, it actually occurred 640 years ago. Analysis indicates most energy would be carried by neutrinos, near light speed particles arriving first as warning, then slower gamma rays, X-rays, and visible light. Cosmic gamma rays would destroy Earth's ozone layer, impair plant photosynthesis, disrupting ecosystems. Post-ozone depletion, high-energy particles would generate secondary particle showers in the atmosphere, increasing radiation doses, further damaging environments. To 0.7 million years ago, Earth was bathed in supernova radiation, resulting iron-60 isotopes remain preserved in Antarctic ice cores. Geologists believe this influenced Ice Age climate, causing minor extinction events. Galactically, supernovae occur approximately 50 years, but they concentrate in the Milky Way's center, where elderly stars abound. Our Orion Arm location, suburban. Dust lanes block our view, reducing observations. Ironically, this might explain why life emerged in our solar system 5 billion years hence. Our sun won't supernova, its mass is too small. It will expand into a red giant, then diffuse into a planetary nebula, leaving a white dwarf core. Earth and Moon will be engulfed. During the red giant phase, in the red giant solar system, Mars becomes the innermost planet. Jupiter and Saturn's moons might become new habitable worlds. The end of time 1 billion years hence. Solar brightness increases 10%. Earth becomes a second Mars. 5 billion years. The sun exhausts its hydrogen, expanding into a red giant. Everything within Mars' orbit is consumed. 6 billion years, the sun becomes a planetary nebula. Only a white dwarf core remaining. Of 8 original planets, only the outer gas giants survive. 100 trillion years. All stars in the universe extinguish. All black holes evaporate. New nebulae lack mass for new star formation. The cosmos descends into darkness and cold. Big Bang's primordial heat vanishes entirely. The last illuminating white dwarfs cool into dark, non-luminous stars. Yet dark energy drives continued acceleration. Remnant matter density stretches ever thinner. Cosmic walls fracture. Galaxies disintegrate. Finally, every atom is torn apart. Entropy reaches its maximum. The universe thermodynamically and physically ceases to exist. But Hawking's colleague, Nobel laureate Penrose, proposes a cyclical spacetime. Our Big Bang 13.8 billion years ago might have been a previous universe's end. The universe may not accelerate forever. Future observations might reveal deceleration, then halted expansion, followed by gravitational collapse. From Earth, all galaxies would appear to approach. Cosmic matter density increases, galactic collisions and mergers proliferate. We know Andromeda will collide with us in 3.7 billion years. But in a contracting universe, all galaxies ultimately merge. Stellar distances shrink ... then planetary ... until all matter compresses into a singularity, another Big Bang. In a new universe with different physics, perhaps spatial dimensions change too, no longer confined to three, giving rise to unimaginable life forms. But this process requires trillions of years. Thus, our universe remains in its infancy. Humanity might be among the first civilizations, explaining the Great Silence. If true, we pioneer without cosmic guidance, returning to time's end. From our fleeting perspective, individual lives or civilizations' mere 10,000-year history are but instants against stellar billion-year timescales. We cannot witness cosmic phenomena within our lifespans. Hubble and Webb show us the universe's state billions of years ago. We never see the real-time cosmos overall. Both times and space's boundaries lie outside our light cone. Perhaps somewhere vacuum decay has begun, dissolving the universe at light speed. But for humanity, we exist for but a cosmic blink. Given the chance ... would you leave Earth for other worlds? Among 5,000 known exoplanets, astronomers have identified several second Earths. The most promising, K2-8b, 8 times Earth's mass, 120 for light years away, orbits a red dwarf every 33 days, though seemingly close to its star. Red dwarfs are cooler than sun-like stars. K2-8b likely resides in the habitable zone. In 2019, University College London scientists detected water vapor in its atmosphere, implying hydrogen, oxygen, possibly methane, and nitrogen. Conditions suitable for life. Even without life, water vapor alone makes it potentially habitable. The main challenge, its gravity. But K2-8b isn't the only candidate. Kepler for 5 to be a super-Earth 1,000 for 100 light-years away. 5 Earth masses. 385-day orbital period, similar to Earth. But its star, Kepler for 152, is older and brighter than the Sun. Strong greenhouse effects might make direct habitation difficult. Besides exoplanets, the Moon and Mars could become humanity's new homes. As Earth's population grows and space resource exploitation expands, humanity's entry into the space age is inevitable, only a matter of time. The key technology isn't reusable rockets, but space elevators enabled by material science breakthroughs. Only these can transport masses and cargo into space affordably. Eventually, space-based industry could launch ships from orbit to the Moon and Mars, maximizing efficiency. Then, the first ordinary civilians to the Moon and Mars will become focal points. Unlike earlier scientific missions, space development's main workforce will be briefly trained civilians. Thus, space and other worlds can become true new homes, not just research bases. Current technology requires approximately 1 week to the Moon, 6 months to Mars. Future advances may have these durations. The Moon could sustain via Earth's supplies, but Mars development must be self-sufficient. creating a new world independent of Earth. This dynamic, reminiscent of Europe and the Americas, might spark conflict between Martians and Earthlings. Human civilization could fragment into smaller cultures across vast distances. Many sci-fi works explore this fragmentation trend, as Asimov's Galactic Empire series depicts a galaxy spanning humanity splintering into smaller civilizations. Ultimately, light speed's unbreakable limit prevents timely communication between settlements. This outcome seems unavoidable. Betelgeuse, a supernova in waiting. In 2019, astronomers observed Betelgeuse dim by 30%, with material ejections from its surface. Though brightness recovered, instability grows. Given its 640 light-year distance, the last naked-eye supernova occurred 900 years ago. Since then, galactic supernovae required professional equipment for observation. Thus, Betelgeuse imminent or already exploded became a prime astronomical target as a red supergiant. Betelgeuse masses 15 suns, diameter 1,000 suns. Swapping it with the Sun would extend its edge to Jupiter's orbit, swallowing Earth. Angular momentum conservation means current expansion slows its rotation. Surface plasma boils unpredictably. Internal hydrogen exhausted. Heavier elements now fuse. Theoretically, post-explosion, neutrinos would reach Earth first, lighter particles outpacing radiation. On 640 light-year scales, they'd arrive hours earlier. Then visible light from the explosion, Betelgeuse would outshine the full moon. Visible daytime, casting shadows at night. This would last 3 to 6 months. The 1054 guest star allowed nighttime reading without lamps. The Crab Nebula remains its remnant. Post-Betelgeuse explosion, its debris would form a new emission nebula, announcing to all observing civilizations a supernova occurred here. Cosmically, supernovae are crucial, like bees pollinating plants on Earth. Indispensable. Without supernovae, no life. Initially, the universe lacked heavy elements. They formed inside first-generation stars, then scattered via supernovae, creating heavy element-enriched nebulae. Second-generation stars like our Sun formed from these, inheriting heavy elements to form rocky metallic planets, eventually yielding life composed of those elements. Thus, the Sun, Earth, us, all Earth life 5 billion years ago were the same. Heavy element nebula's constituents. Earlier, these elements were trapped inside first-generation stars' cores until supernovae liberated them. Future Betelgeuse observations won't just mark a star's death, but possibly new stellar and life beginnings. Cosmic civilizations beyond imagination. Level 7 civilizations. To them, humanity resembles ants. At this stage, civilizations likely achieve pure energy transformation, existing independent of matter, perhaps altering cosmic laws, exercising absolute control over regions, barring other civilizations' entry. The Kardashev scale originally defined levels I3, planetary, stellar, galactic civilizations. Humanity currently ranks approximately 0.7. Not even level I. We lack controlled fusion and full planetary energy utilization As cosmic understanding deepened, scientists realized level 3 isn't the pinnacle. Thus, levels IV7 were added, from basic fusion mastery to ultimate energy transformation, spanning a civilization's entire technological trajectory. For us, approximately 300 years might achieve full Earth resource control. Then advancement toward level 2 begins, the key technology, Dyson spheres encasing the Sun for power. Since the Sun comprises 99.86% solar system mass, we might dismantle most planets for construction materials. Building a Dyson sphere could take centuries, during which stellar brightness fluctuates irregularly, potentially revealing our cosmic coordinates. Previously observed Tabby's star dimming was speculated as alien Dyson sphere construction. For level 3 civilizations, stellar scale energy becomes insufficient. Galaxies with hundreds of billions of stars, spanning to 100,000 light years, become targets. Beyond enveloping stars into Dyson spheres, they might harness supernova energies and black hole jets. Levels 4V needn't worrying about energy. Spacetime's fundamental properties become their new frontier: wormholes, spacetime folding, multiverses, higher dimensions. In these realms, they could dimensionality crush original cosmic civilizations. Mastering multiple parallel universes elevates them to level VI cross-universe civilizations. Level 7 achieves true energy transformation. Now the universe becomes, then they become the universe. Perhaps only one such civilization exists per cosmos. Individual distinctions vanish. All merge into a unified entity. Perhaps our universe itself is a level 7 civilization's dream. Many scientists ponder a simulated cosmic existence. Astronomical observations show galactic distributions resemble neural networks, near identical to brain neuron layouts. We might be brief dreams in a cosmic mind, those scaled to seem eternal. Ultimately, physics demands evidence. No matter how elegant, logically and provable, unfalsifiable concepts remain unestablished. The only question: can all cosmic existence be proven or disproven? Why no continents on Earth's far side rotate a globe? Almost all continents cluster on one side. The opposite hemisphere, vast Pacific Ocean, Point Nemo, the ocean's pole of inaccessibility, lies farthest from land. The nearest human artifact, the 400 km high space station, the nearest continent to 800 kilometers away, as Earth's largest ocean. The Pacific spans 165 million square kilometers, approximately 30% of Earth's surface, larger than Mars' entire area. Why no continents in this vast region? Wegener's continental drift theory holds the key. First, understand Earth's land area isn't constant. Eons of plate mergers and splits have submerged much land. Pangaea, the earliest supercontinent, covered to 100 million square kilometers. Plate tectonics fractured it into today's layout over 4.5 billion years. Earth's continents underwent at least 3 major cycles, plus 5 mass extinctions. Cross-sectioning Earth reveals our solid ground is but an eggshell floating on a magma sea. Earth's core and mantle convect, driven by heat. This motion drives tectonic plate movement. The Pacific plate is vast yet low density. It subducts beneath other plates, forming massive structures. Plate boundaries become the seismically active ring of fire. This belt perfectly isolates the Pacific plate, leaving it ocean-covered. Only 25,000 islands dot the Pacific. Distance and supply challenges leave many Pacific islands uninhabited. Previously mentioned Point Nemo's remoteness makes it a spacecraft cemetery. Controlled orbits target this region. Current plate motion suggests future continents will continue moving. The Pacific plate shifts approximately 1.5 kilometers yearly. Eventually, all continents might merge into a new supercontinent, evolving dinosaur-sized land fauna. But this is too distant for us on the Cartier scale. Humanity ranks (0.73 within 300 to 500 years. We might achieve level 1 civilization, initiating solar system development. Earth's importance will diminish. The Moon and Mars become new homes. As space development accelerates, more people working and living in space will transform humanity into a spacefaring civilization. Earth's primacy will fade. The solar system offers hundreds of habitable worlds, resources dwarfing Earth's. We needn't remain confined to our cradle. How vast is the true universe? Astronomers often cite the observable universe is 93 billion light-year diameter, but this is merely a tiny fraction, a special region where galaxies' light can still reach Earth within this sphere. Hubble found the trillion galaxies. 98% have already disconnected from Earth. Due to superluminal expansion, their light, receding faster than light speed, never reaches us. Thus, we see all galaxies as they were, never as they are. Astronomers estimate at 14.6 billion light-years. Cosmic expansion officially exceeds light speed. Once galaxies cross this line, they share no causal relationship with Earth. The true cosmic volume, at least 250 the observable universe. This figure stems from curvature measurements. Though we can't directly measure cosmic size, microwave background maps reveal galaxy distribution densities across directions, outlining part of the true universe. Observing this portion's curvature, we've confirmed a flat, infinite spatial structure. Though slightly warped, this nearly imperceptible curvature suggests expanding the observable universe to 150 would close curvature into a sphere the true cosmic size. Einstein's general relativity predicted such closed hypersphere universes. He also suggested, in such a cosmos, one could see their own head, light following geodesics in curved space. With sufficient curvature, light emitted backward would circumnavigate the cosmos and return. Similarly, light speed travel here would mimic Earth's circumnavigation, always returning to the starting point. Thus, we might never leave the universe. Multiverse or parallel universe theories lack evidence currently, but perhaps light speed is merely a barrier, not an unbreakable law. Science believes superluminal travel could escape this closed cosmos, like achieving escape velocity from Earth, perhaps exceeding light speed, opens new directions beyond the universe. In the bubble universe model, our cosmos is one of many bubbles in a higher dimensional space, each with different physical laws. Leaving our universe for others isn't easy. Different laws might disintegrate foreign matter, Of course, a simulated universe remains possible. Many luminaries, including Musk, espouse this view. Perhaps we're merely NPCs in a vast cosmic simulation. Do aliens truly exist? 1962, humanity first transmitted radio signals to potential cosmic civilizations. Despite 60 years of silence, scientists persist. Astronomers believe gravitational wave detectors might be optimal for finding aliens. Gravitational waves arise not only from colliding black holes, but also highly relativistic spacecraft, per Einstein's mass energy equivalence. Near light speed alien ships would exhibit terrifying mass inflation, distorting surrounding space-time, generating powerful gravitational signals. In 2015, scientists first detected gravitational waves from emerging black holes 1.3 billion light-years away. Thus, if alien light-speed craft traverse the Milky Way, we might detect their gravitational waves. The catch: gravitational waves also travel at light speed. By detection, the ship might have left the galaxy long ago. Extrapolating from wave strength, such alien craft at near sea would mass like Jupiter, but volume perhaps only moon-sized or smaller. How many Jupiter-mass high-velocity objects exist in the Milky Way? Answer: 170. Each matches Jupiter's size. If aliens found ways to accelerate them near light speed, the resulting gravitational waves would be detectable by current instruments. In other words, aliens might pilot entire planets at high speeds. This seems improbable, but if they employ warp drive technology, accelerating a planet differs little from a ship. Planets offer constant gravity, ample space and resources, surface protection from space radiation. The Death Star from Star Wars exemplifies this. Moon-sized, interstellar capable, housing millions. 2017, scientists first discovered an interstellar object, a cigar-shaped comet. Oumuamua. This extraterrestrial visitor approached Earth at 87 kilometers sec. Though now departed, some astronomers speculate it might be a velocity-adjustable spacecraft. We might encounter it again. Another possibility: aliens might arrive in our solar system suddenly, but this probability is minuscule. Humanity's current temporal window is but a blink in Earth's 4.5 billion year history. Unlikely for aliens to visit now. Perhaps aliens visited Earth 65 million years ago, but dinosaurs couldn't record this. Overall, whether using gravitational waves, probes, or radio transmissions, our technological methods remain primitive. At this rate, we might not find aliens for centuries. Is faster-than-light travel possible? A laser pointer aimed at the moon. A slight wrist flick moves the spot 380 kilometers away. This superluminal motion is phase velocity, a non-material phenomenon since it carries no information. It violates no physical laws. What we truly need is FTL ships, like Star Trek's Enterprise with warp drive, encasing vessels in space-time bubbles, circumventing light-speed limits, but current theory forbids this. Einstein permits approaching light speed, not reaching or exceeding it. You might think light speed is fast, circling Earth 7.5 per second, but cosmically it's snail-paced. The most distant known galaxy, G and Z11, lies 13.2 billion light-years away. We see it as it was 13.2 billion years ago, worse due to superluminal expansion. Its current distance is 18 billion light-years and increasing, in fact 13.82 billion years post-Big Bang. 98% of observable galaxies have already disconnected from Earth. We see only their ancient light. As cosmic expansion continues, stars in Earth's night sky will redshift beyond our light cone someday. Gazing up will reveal only solar system planets, no other stars. Though Einstein forbade FTL travel, he left a loophole, a tunnel connecting distant cosmic regions, the Einstein-Rosen bridge, or wormhole. Recent studies suggest wormholes could enable effectively infinite speed travel between spatial locations, if beyond our 3 spatial and 1 temporal dimensions lies a 5th dimension with concentrated quantum fluctuations, then sufficiently advanced civilizations might use wormholes like subways. But science has never observed a 5th dimension, even if existent. Exotic matter-negative energy would be needed to stabilize wormholes. Otherwise, traversing unstable wormholes would shred all particles beyond reconstruction. Worst, wormholes don't avoid time dilation while you experience 1 second inside. External time might advance millennia, returning to find everything changed. During July 2023 congressional hearings, U.S. Air Force officers and former intelligence officials claimed UFOs might be alien FTL craft. From light years away, scientists largely dismiss this. Any FTL motion would leave obvious cosmic traces. Overall, while FTL remains distant, future general relativity developments might unlock space-time and gravity's nature, enabling new propulsion technologies. Was our universe's birth accidental? Einstein and Jan Jennings both leaned toward a non-personified creator's existence. Otherwise, the universe's first cause remains unsolved. Note, they referenced a non-personified creator, meaning behind it lie cosmic laws and mechanisms beyond current human understanding. Lacking these, we cannot explain why the Big Bang occurred, or our own existence. Physically, our universe seems fine-tuned. Several constants appear delicately balanced. Minute changes would preclude cosmic existence. For example, nuclear fusion's mass energy conversion rate, 0.6%. This reaction rate determines stars' long-term fusion sustainability. Slightly lower stellar fusion wouldn't ignite. Higher stellar lifespans would be too brief for planets, life, or civilizations beyond macroscopic constants. Microscopic parameters ensure particle stability. The electromagnetic coupling constant dictates electromagnetic force strength, representing the electron-photon emission. Absorption probability, even for percent deviation, would prevent biological molecular chains precluding life. Based on such observational facts, some leading physicists favor a non-personified creator's existence. Some radicals propose our universe is an elaborate program. Most being NPCs, we think we discover cosmic laws, but merely operate within preset frameworks. A common alternative, multiverse theory. Our universe is one of many cosmic bubbles, like planets with varying gravities. Different universes exhibit different laws. Our apparent fine-tuning is mere selection bias, inevitable across countless universes. Perhaps other universes have 30,000 kilometers, sec light speed, still yielding life adapted to those laws. Thus, neither our universe nor us are special products. Whether our universe is simulated remains unproven. We haven't found cosmic bugs. Some suggest 300,000 kilometers, sec light speed, is an air wall preventing NPCs from leaving boundaries. Quantum superposition addresses rendering loads, but truly understanding cosmic laws requires approaching them, not speculation. Unfortunately, human spacecraft velocities remain under 1% light speed. We barely explore Earth, Moon, and Mars effectively. True interstellar civilization lies far ahead. Perhaps future computers could simulate a miniature universe populated with AI life if they never discover their simulated nature. Perhaps we cannot prove our own vacuum decay, the ultimate cosmic reset. You might not believe it, but scientists think vacuum decay could destroy the universe any time. Once triggered, all material structures would obliterate. The cosmos would reshuffle at the particle level, new physical laws emerging, essentially another Big Bang. A fundamental physics principle, vacuum decay relates to lowest energy ground states. In any system, energy spontaneously seeks lowest levels. Like a hilltop ball, a slight push sends it rolling down. A classic descent to lower energy. Our universe contains various invisible fields: gravitational, electromagnetic, quantum, most importantly, the Higgs field. The Higgs boson gives particles mass, the universe's most fundamental field, but the standard cosmological model sits in a metastable Higgs field state. Our universe might be a hilltop ball, vulnerable to minor perturbations, plunging into a lower energy valley. Physicists call this unstable cosmic state. False vacuum or pseudo-vacuum. Our seemingly stable universe might be a transient phase in dynamic equilibrium. Vacuum decay might be occurring now, spreading light speed across the cosmos. We could never know in advance. Another key question: what energy release triggers vacuum decay? Liu Cixin's The Wandering Earth depicted an equatorial collider matching Big Bang energies, capable of inducing vacuum decay. Aliens halted it to prevent catastrophe. In reality, the most powerful collider, the LHC, accelerates particles near light speed, but its energy density falls far short of recreating Big Bang conditions, not even producing black holes. Other cosmic phenomena also lack sufficient energy density to push the universe from metastability. Thus, our universe seems safe. But quantum mechanics governs the cosmos. In the unseen microscopic realm, quantum fluctuations constantly occur. The universe's stability is inherently quantum, uncertain. Thus, anywhere could spawn vacuum decay, altering the universal state. If decay occurred in our solar system, Earth would dissolve into fundamental particles. Solar system physics would vanish. The new vacuum would spread light speed outward. Witnessing vacuum decay means instant dissolution, painless. If decay began elsewhere, its effects might take millions, even billions of years to reach Earth. By then, human civilization might already be extinct. Voyager 147 years and counting ... When will it die as the most distant human-made object? 24.3 billion kilometers away. Voyager 1 retains only basic response functions. All scientific instruments are off. Nuclear battery power dwindles. NASA engineers estimate 2025 will exhaust all power. Permanent silence. Within NASA, Voyager projects essentially concluded. Only a small team monitors them. But original project scientists and engineers, now elderly, cannot retire. 1970s programming languages and techniques. Only they understand. For the public, Voyager 1's greatest contribution. First close-up images of outer solar system planets. Pre-Voyager, astronomers barely reach Mars ... using gravitational slingshots. Voyager captured Jupiter, Saturn, Uranus, Neptune. But its most meaningful image, the 1990 pale blue dot, Earth from 6.4 billion kilometers away. No details, a barely visible speck, 0.1 pixels wide. This dot hosts 8 billion people, our only home. Before this, as Carl Sagan said, that's here, that's home. That's us, you might not believe it. Voyager 1's data rate, 160 bits sec. A 1 megabyte image requires greater than 7 hours transmission. Now, rates are even lower. Communicating takes greater than 20 hours round trip. The most information-dense component, the golden record, containing Earth's sights, sounds, multilingual greetings. It's cover-etched with pulsar maps, locating our solar system in the Milky Way. Any alien civilization finding it could derive a universal time unit from pulsar rotation periods. Calculate Voyager's launch time, combined with pulsar positioning, pinpointing Earth's galactic location. If Liu Cixin's dark forest theory holds, the golden record is dangerously revealing, but astronomers deem alien encounters unlikely. Both records ride Voyager spacecraft velocity, 17 kilometers sec, 30,000 years to leave the 1 light-year radius solar system. 30,000 years hence, human civilization's location is unknown. Unless aliens suddenly enter the solar system, they won't encounter Voyager's post-battery depletion. Both will continue orbiting. Perhaps future humans could retrieve them from museums. Technologically, Voyagers seem primitive. Primary propulsion, gravitational slingshots. No solar panels, products of early space age. Unfit for true interstellar messaging. NASA's golden records target humanity itself. In actual space exploration, current chemical propulsion is primitive. Nuclear fusion, antimatter, light sails all outperform current technology. We've developed 1% of existing theory. General relativity permits wormholes or warp-drive light-speed ships. Currently beyond reach, relativity is over a century old. Our space propulsion still relies on 300-year-old Newtonian reaction forces. Thus, Voyagers are far too slow. Future advanced probes might overtake them in months. Hubble's greatest hits, the universe in pictures. Don't blink, you're seeing one of Hubble's top 10 images, the pillars of creation, terrifying yet beautiful, located in the Eagle Nebula, 6,500 light-years away. Interstellar dust coalesced by gravity, vibrant colors indicate different nebular materials. Inside these pillars, infant stars await birth, hence the name, Pillars of Creation. But astronomers believe they might already be gone. Hubble observations suggest a nearby supernova shockwave likely dissipated them. We see their 6,500-year-old light. This is the Hubble Extreme Deep Field, months-long exposure cosmic portrait. Every speck of light isn't a star, but a galaxy like our Milky Way. Each hosts hundreds of billions of stars. Conservatively, this image contains 10,000 galaxies, covering 1.27 million of the sky. Thus, the 93 billion light-year observable universe holds at least 2 trillion galaxies. Our Milky Way, solar system, and us, cosmic space. Hubble's most distant galaxy, 13.2 billion light-years. We see it as it was 13.2 billion years ago, the universe's infancy. Thus, cosmology is cosmic archaeology. The deeper Hubble looks, the closer to the Big Bang. Without Hubble, we'd never see these distant realms. Though aging, its career delivered countless stunning cosmic images, repeatedly laying our cosmic understanding for NASA's original plan. Hubble should have retired in 2005, replaced by Webb, but Webb's delays and Hubble's resilience keep it operational today. Astronomers believe it might last until 2030. Moreover, Webb primarily observes mid-infrared, not visible light. Thus, Webb's images differ coloristically from Hubble's. Only Hubble captures universe colors as human eyes would perceive. Future Hubble observations will complement Webb's, exploring the cosmos together, but neither Hubble nor Webb can resolve exoplanet surfaces directly. Their apertures are too small. Astronomers propose using Earth's or Sun's gravitational lensing. Placing telescopes at appropriate distances could create Earth or Sun-sized apertures, theoretically resolving Proxima B's surface. If such gravitational lensing telescopes materialize, we might find alien traces without dispatching probes. What lies beyond the cosmic age? Astronomers tell us the universe expands faster than light. Then what lies beyond? Currently, 3 answers. First, the universe might be finite. In this case, a boundary exists, but not in 3 dimensions. In higher dimensional space, thus, our universe, like Earth, is finite but unbounded, only achieving certain velocities, lifts us from 3D space into 4D, revealing the cosmic whole. This new velocity, per Einstein, is superluminal, transcending spatial dimensional limits. Without FTL, spacecraft resemble ocean vessels on Earth, no matter speed or straightness, eventually returning to origin, lacking an extra dimension to escape. Unfortunately, 4D space remains mysterious. Limited research exists, mostly mathematically. Quantum physicists suggest discovering curled-up microdimensions might release them macroscopically, but this remains speculative. Second, our universe might be infinite and superluminally extending infinite plane. Then boundaries become meaningless, receding faster than pursuit. Current observations indicate zero curvature, absolute flatness. Third, the familiar multiverse theory, a finite universe we could eventually leave, entering broader space, hosting other universes, like planets within a cosmos, but new questions arise. What contains the multiverse? Facing this infinite regression, astronomers lack good answers. Hubble and Webb cannot see the cosmic age. The deeper they look, the closer to the Big Bang. We see cosmic history, not present or future. From cosmic hierarchical structures, base level, Earth, then solar system. Galaxies are cosmic fundamental structures. Multiple galaxies form groups, which form clusters. Then superclusters like Laniakea, scales reaching billions of light years. Galaxies manifest web structures. In this cosmic web, trillions of galaxies form cosmic walls. Superclusters act as nodes between walls. Dark energy-filled voids separate them. Interestingly, human neural networks resemble the cosmic web. Science's answer: brains and cosmos follow the same physical laws, maximizing efficiency within finite space. Thus, regardless of cosmic boundaries, exploration remains imperative. After all, intelligent civilizations are cosmic rarities. Without cosmic exploration, humanity might indeed become the sole intelligence. The final message within the observable universes, to trillion galaxies, ... Are we truly alone? University of Nottingham researchers published new astrophysical studies, estimating at least 36 alien civilizations in the Milky Way. This precise number stems from the Milky Way's 100 billion stars, our Sun among them. Galactic age, 12.8 billion years. Solar system age, 5 billion years. If life requires approximately 5 billion years evolution for intelligent civilization, then civilizations capable of interstellar communication number at least 36, all carbon-based Earth-like planets. But a existence does not equal contact. Finding them or being found proves difficult. Thanks to galactic gravitational equilibrium, average stellar separation spans approximately 5 light-years. Proxima Centauri, 4.22 light-years away, the nearest alien world, but human technology remains 1% light speed. Galactic exploration is unimaginable, thus we cannot find aliens. Some astronomers hope for alien visitation, but as one of billions of galactic stars, our solar system's peripheral location makes direct alien selection unlikely. They'd likely explore the galactic center. More stars, potentially more civilizations. Beyond spatial challenges, time disfavors us. Humanity only recently gained capability to detect space visitors. Earth existed for 0.6 billion years prior. Even if aliens visited every 10,000 years, we'd likely miss them, existing in a temporal sliver, though many believe. 4 light-year distant Proxima b is a habitable zone planet potentially hosting life. Statistically, to intelligent species, being neighbors is astronomically low. Reality: the galaxy's few dozen civilizations might be separated by tens of thousands of light years, precluding effective communication. Currently, humanity's active transmissions reach only dozens of light years. Voyager 1 needs 30,000 years to leave the solar system. Thus, astronomers believe, even for advanced aliens, galactic exploration is immensely challenging. Their detectable range might be mere hundreds of light years among Earth-like exoplanets. Kepler-60 to east, 1,000 to 100 light years away, with 1.6 Earth's volume, is highly anticipated for potential life. Its star is smaller, cooler than the Sun, shielding Kepler 6b from stellar baking. It might be completely ocean-covered, all life aquatic, no land. Universally, even one civilization per galaxy means to trillion civilizations. In the observable universe, and the observable cosmos is but a tiny fraction of the whole. True civilization numbers might exceed imagination. Thus, humanity isn't alone. Next time you gaze at the stars, remember we are minuscule existences. In this cosmos, humanity isn't the protagonist, merely one among many. The universe whispers ... Are we listening?